what was that? We started with an exponential model last time. We can either pick the bacteria problem or we can pick the BAC problem. Which one do we want to pick?
I say bacteria.
Bacteria. Okay, so this is the bacterial growth problem. And the model that we obtained last time was A of t is equal to 500 to raise, what was the rate? I believe it was to t. Yes, no, that was last time. And of course, I could rewrite it another way, 500 to raise 2 raise t. And 500 full raised t. Yes. Now, why did I not show this last time? Because I don't want to change the base. I just wanted to keep it at 2. I'm doing it now because I can use logarithms. So, why did we choose 2 specifically?
To simplify it, since we hadn't exactly covered the concept of using logarithms.
Very good. So to simplify, because we did not cover the concept of logarithms. Initially, we wanted to go with the part which has the exponential. That we didn't do. So we had a of t as a power of 2. So I expressed it in power of 2 so we can equate the powers. Here I have a power of 4. That's okay too. Last time I mentioned you can cancel out. Oh, we get music too today. So log base A and A will get cancelled. You would end up getting x. So the way to get rid of logarithms is simply getting x. Excuse me. The way to get rid of exponential is to apply logarithms. What was the last part that we did? Find the time when.
Find the time when the alcohol at the very least is at 0.3.
We're talking about bacteria.
Oh, my fault.
How many bacteria are there after 3 hours?
Okay, that's time. So there was a problem. Yes, find the time when we have 100,000 bacteria. Yep.
Oh, yeah.
Yeah.
Yeah, this is where my algebra went out in terms of calculations last time. So now we have 100,000 bacteria, so we just have to solve for t. Yes, so I'm going to start with the first one. So A of t is equal to 100,000. Yes. We have to set A of t equal to 100,000 and solve for t. We can cancel out 2 zeros, 1,000 over 5. I'll get it right this time. It's 200. And that's what we have. And last time we did a whole lot of guesswork, trial and error to get to the correct answer. Then the BAC problem, we used the trace function to get the correct answer. Now we're going to do logarithms. So if I have to get rid of that 2, I need to take base log 2 on both sides. Right, so that's the only way to get rid of that 2. So I would have log base 2 or 200 equals log base 2 of 2 raised to 10. Can you still see? Other side, can you see? Okay. Those two will go away. And we have that. What makes so far? If you have your calculator, go ahead and grab it. I want you to search and find log base 2 for me. On your calculator, go ahead.
All I'm saying at the very least, because I'm currently specific. There was a formula at the very least for putting your own custom logarithm.
Okay, so if you look in the calculator, it has ln and it has log, right? So what we want is we want to have log base 2. So in general, this is a remark. Natural log, excuse me, log base a of x is simply natural logarithm of x divided by the natural logarithm of a. If you look in the calculator, you have the ln button. Yes. So all you need to know is remember this formula. The x value will go there, and the a, the base, is going to go there. So in our case, the base a is 2. The value x is 200. Good. So we want to evaluate that. So 2t would be equal to ln of 200 divided by ln of 2.
So ln of product over ln of base equals to log.
Yes. Good so far. So let's find what 2t is. It's a new view. The next time I'm dividing the sections so that we don't get all the text driving me nuts.
We could also just put that up and you'd have a.
Then I have to move the camera every single time. I guess we can do it. ln of 200 divided by ln of 2. 7.643, and we've simply got to divide that by 2.
That would be 3.82.
3.82 hours. I want you to go back and look at what we did. You should have the same answer. If not, my entire life is meaningless. It better be 3.82.
Oh, wonderful. Now we don't have to find
Good.
any future.
I had in terms of base 2. Can I erase all of this? Okay. Same process, but I'm going to use that 4. So that would become 4 raised t.
Also, a quick tip as well, when it comes down to the natural logarithm, to do a custom of that, you just do the same thing with swap. Well, there, so now you have natural logarithm at the very least is equal to logarithm of the product over logarithm of the base.
If we don't want that, we want to represent log of any base in terms of natural logarithm, because in mathematics, when we say logarithm, by default, it will point to natural logarithm. So we like to write everything in terms of natural logarithm. Okay, so 200 is equal to 4 raised t. That is our new equation. Now, if we want to solve that equation, what logarithm should we take on both sides? 4. So log base 4 of 200 would be equal to log base 4 of 4 raised to 2. Good. Those two will go away. So t would be equal to log base 4 of 200, which would simply mean ln of 200 divided by ln of 4. Agreed? So let's use the calculator and find this value. To get the same answer. You should get the same answer, 3.82 hours. Yes? Did we?
Yeah, this one, at the very least, I just realized, when it said it doubled every half hour, not every hour, so. Wouldn't that at the very least mean we would have to go on as well since?
Well, it's not a linear model, it's not going to increase in a linear fashion. It's an exponential model. It starts out slow and it just rapidly grows.
Oh, I was just thinking because the original units that we were given for half hours, that's why.
Yeah, so still an hour, right? The unit of measurement is hours. So we use the time at half hours to find the initial value, I believe.
So doesn't that mean that the rate, if we're measuring it instead of hours, would be quadruple, not double?
No, once again, it's because it's an exponential model, not a linear model.
Oh, my apologies.
Yeah, if it's a linear model, sure, it'll, work that way, but this is an exponential model. We get the same answer, right? I want you to go back and read that question. And if I recall correctly, they gave us the amount of bacteria at time t equals 30 minutes, 0.5 hours. Correct? Or was it 1.5? At t equals 30 minutes, which is 0.5 hours. The amount was 1,000. And they didn't know the initial value, correct? And that's the first step. We wanted to find the initial value and we wanted to find the rate also. Or did they give us the initial value?
Yeah, they gave 500.
500, they gave 500, okay. So A of 0 is 500. Good. Now I want you to fit the model. A of t is equal to, I'll call this A naught E raised k times 2. Good. Switch the base. So this is 1,000. That is 500. T would be 0.5. So we want to solve for k. I'm going to erase this part. So 1,000 would equal to 500 e raised k multiplied by 1/2. And divide by 500 on both sides. 2 would be equal to k raised 1/2. Yes.
Let's do that one more time. Sorry, can you just repeat that one more time?
So A of t is 1,000, it is 1,000 when t is half an hour. So I put half. The initial value is 500. So I get that. So divide by 500 on both sides, I'll get 2. I want to get rid of e, so I'm going to take log base e on both sides. That's going to go back on. But you may say, well, how would I put that in the calculator? Well, log base e implies it's ln of 2. So that would be ln of 2 e raised. Okay, oops, the e goes away, my bad. K over 2. So you put that all in, what is k?
Wait, why is it 1.2?
Okay,
How did you get K over 2?
0.5.
Oh.
0.5 is 1/2.
Over
Oh,
2 is the
okay.
same thing.
So it's k over 2.
Okay, I'm sorry.
So k times 0.5 is k over 2. With me? Okay. So what is the answer? 1 point, I believe it's 386.
I'm more so meant why exactly you said you're doing ln of 2, and you're talking about 100,000, not 1,000.
No. We are trying to find a model of this kind.
Oh, my apologies.
Yeah. So A of t would be equal to 500. We found the rate, which is e, 1.386, and multiplied by t. I want you to take a moment and compare this to what we had previously. Yes.
Oh,
Well, maybe you're right. What was different?
how did you get the 1.386 exactly?
ln of 2 using the calculator multiplied by 2 on
Oh,
both
you multiply that?
Yeah, because it's k over 2.
Yeah.
So you have to multiply by 2.
What's it say at the bottom? I can't see it.
K equals 1.386.
Thank you.
Okay. I want you to take a moment and go back to the normal stuff. The first one, 2 raised to t. So for base 2, the rate was 2. The second one, it was 4 raised t. For base 4, it was 1. So this is base e. For base e, the rate is 1.386. Does that make sense? So if you switch the base, you're going to get different numbers, but in most cases, they are proportional to each other. I'll give you a second or a few seconds to find out the value of t when A of t is 100,000. Even with all doing this, well, what do you think the answer should be? Huh? 0.5. At 100,000, not 1,000. 3.82. Remember, 2 raised t, 4 raised. Let's see if we get the same 3.2. 3.82, I mean. So we need to get 3.82, but our new model here is A of t equals 500 e raised 1.386. We're going to take away all kinds of guesswork and get to the answer directly using logarithms. So 100,000 would equal to 500 e raised 1.3862. Divide by 500 on both sides, you will get 200 equals to e raised 1.3862. What logarithm should we take? Ln on both sides, which is simply base e. Those two would go away. So ln of 200 would be equal to 1.386 t. So t would be ln of 200 over 1.386.
3.82.
3.82. Good.
Which is close enough to our original estimate of these two that we can kind of say.
Yes, it's exactly, so science doesn't mess around, it's always exact and it's very factual. So, as you can see.